Good morning to all.
Good morning, sir.
Morning, sir.
This week, if I'm right, we have 3 lectures, right?
Yes, sir.
The third lecture will be exclusively a doubt lecture.
Of what?
Doubts of what?
TV.
Doubts of the homework that you people will get today and tomorrow.
Oh,
And next week.
Okay, sir.
okay, sir.
Electrostatics ka basically.
Huh.
You have been given some homework from HCV.
Yes,
sir.
sir.
You have
Yes,
been
sir.
given an assignment sheet.
Yes, sir.
Yes, sir.
Yeah. Today's
So
lecture,
ग्रेविटेशन का HCV कब करेंगे?
whatever it is. जो भी है, the third lecture will be doubt lecture. अगर gravitation का कुछ pending है, we'll first finish gravitation and come to electrostatics.
Okay, sir.
Right?
Yes, sir.
Second. This is flagship or 3 years batch?
Flagship.
Okay.
सर क्वेश्चन आप क्लास में डिस्कस करने वाले थे इन द प्रीवियस डाउट लेक्चर आई आस्क्ड यू 2 क्वेश्चंस फ्रॉम द असाइनमेंट
वो सर एंड में करेंगे ना, डाउट लेक्चर है ना?
सर ने मेरे को बोला कि क्लास में एक बार पूछना
कौन सा क्वेश्चंस यार?
40 and 40 सेकंड
So that's from the assignment.
हाँ
डाउट लेक्चर में कर दूं.
ओके सर
असाइनमेंट्स कितने दिए मैंने आपको? एक.
Yes, sir.
दूसरा असाइनमेंट भेजा नहीं मैंने.
नहीं, sir.
Okay. What was the last thing I covered in your batch?
So we dealt with that holosphere wala problem that sigma is equal to AR, that one. A is equal to
So
constant.
vertical sphere, vertical motion. हाँ सर की vertical circular motion जो भी है वो. हाँ, and then we did some questions from the booklet and you gave us 2 questions also from Mirodov mostly. Azimuthal angle wala.
And holosphere.
Azimuthal angle sigma is A into R.
Yes,
Yes,
sir.
sir. Holosphere.
Okay, that was the last question we did.
Okay. We are slightly safe. 2 things that I need to ask. Booklet say, did we deal with 2 passages or only 1 passage?
2 times, sir.
2 passages.
2 passages. Okay. Did we deal with a ring and a bead given velocity of u and capital Q is fixed here?
Yes.
Yes,
Yes, sir.
sir.
Yes, sir.
So that was like 1 or 2 classes ago.
Yes, sir.
Just confirming it since in some batch I forgot. Pendulum bob is released, electric field you people have done. Okay. Then we can go to the dipole field. 1 second, let me see. If we have not. Okay. We have done field inside a cavity.
Yes, sir.
Motion in a vertical circle. Minimum velocity to be given for it to complete a circle.
Yes, sir.
Yes.
We have done application of electrostatics and mechanics quite a lot. Field. Fine. Electric length of force, charges, so on and so forth. Dipole field. Technically, HCV split this chapter electrostatics into two parts. Till here, he dealt with field and potential, and then Gauss law separate. In fact, that's a very wise decision. In fact, till now, if you people observe, we are yet dealing with application of mechanics in electrostatics. Now, SHM कहाँ तक हुआ है?
We've done phasor.
Sir, we done
सर
the
जितना आपने
dynamics of
करवाया
SHM. We just started dynamics of SHM.
Okay.
sir.
Did you people do time period of a simple harmonic motion in an accelerated frame?
No, sir.
No, sir.
ये थोड़ा SHM नहीं होने के कारण, but it's okay. I'll
Sir,
cover
we had
Sir, we-
done it in gravitation, right? We had done it in gravitation time period wala thing.
but not on accelerated frames. Have a look at this.
Sir, you write it. We'll just accept it for now.
I derive it. क्यों? कौन सा जल्दी में है? The frame is accelerating with an acceleration of a0. Both will be in equilibrium. Do you agree with this?
Yes, sir.
Pseudo force on this will be ma0 and mg. What is the time period of a normal simple pendulum of short length? 2 pi under root L by G. Nobody has a doubt in it, right?
Yes.
We derived it. Now, it is in an accelerating frame now. This is not the equilibrium position. This is the equilibrium position. Agreed? So you will have mg sin theta is equal to me0 cos theta. Because this is theta. This will be theta. ma0 cos theta, mg sin theta. So I get tan theta is a0 by g. Something which will tickle your mind because you know this having done in Newton's laws. You did it with a small change. You equated forces in upward direction to forces in downward direction. Forces towards the right equal to forces towards the left. Agreed?
Yes, sir.
Tan theta is a0 by g is something which I expect you people to know without a second thought. Right? Now what you have done is from the equilibrium you slightly displace it. From the equilibrium position, you slightly displace it. This is theta. Now you have moved it by an angle of phi. Remember in simple pendulum, angle that you displace from the equilibrium should be small. Do you recollect that?
Yes, sir.
Yes, sir.
So here phi is small. Theta need not be small. Theta need not be small. It depends on a0. theta need not be small. Phi should be small. From the equilibrium position, you displace it by a small angle. What will the restoring force be? Mg sine theta plus phi minus m a naught cos theta plus phi. Do you all agree with that?
Yes, sir.
Yes, sir.
All that you did is what was theta here became theta plus phi. So what is the restoring force? Restoring force is mg sine of theta plus phi minus ma naught cos theta plus phi. Restoring force m d2x by dt square. Intentionally, I am not using a here because a naught you have already used. There will be confusion for you people. Or okay, a naught you used. All this as a mass into acceleration. M g sine theta cos phi plus mg cos theta sine phi. Is my calculation correct? Sine a plus b. Say something.
Yes, sir.
Cos theta plus phi, cos theta cos phi minus sin theta sin phi. Yes or no?
Yes, sir.
M gets cancelled out all through. A is equal to. Now tan theta, if I know, A naught by G root over of A naught square plus G. What is sin theta? A naught by root over of A naught square plus G square. What is cos theta? G by root over of A naught square plus G square. Now just substitute the values here. What is sin theta? A naught by root over of A naught square plus G square. Cos phi, when phi is small, cos phi will be 1. You are aware of it. Theta tending to 0, cos theta.
1.
Are you people there?
Cos theta is 1.
Theta tending to 0, what is cos theta?
1.
1.
Here phi tending to 0, phi is small, cos phi will be 1. G sin phi will be 5. Phi tending to 0, sin phi will be 5. And what is the value of cos theta? G root over of A naught square plus G square minus A naught. This will be 1. What is cos theta? G by root over of A naught square plus G square. A naught sin theta, A naught square by root over of A naught square plus G square. Sin phi will be 5. Sin phi will be 5 and phi is tending to 0. This will get cancelled. I will have root over of A naught square plus G square. Phi will be x by L. This distance is x, this is L. So I get A is equal to root over of A naught square plus G square by L into x with a negative sign. So A is equal to minus omega square x. Comparing this equation with minus omega square x, do I get the value of omega?
Yes.
I will rewrite this expression clearly here, take it down till here. SHM in an accelerating frame. Now we have 3 problems in electrostatics to be dealt with based on this. Take it down till here. I'll summarize this result first and then we will deal with electrostatics. SHM in an accelerating frame. Subheading is, write it in your electrostatics notes only. SHM in an accelerating frame. SHM in an accelerating frame.
So if I can take cos phi approximately equal to 1, can I not take sin phi approximately equal to 0?
Limits is taught to you people.
Yes, sir.
Yes,
Yes,
sir.
sir.
So it's not my answer. Limit theta tending to 0, sin theta is not 0. Sin theta is theta.
But
Limit
cos
theta
theta is
tending
1.
cos theta is 1.
You're multiplying sin theta, no? So you can't just simply put 0.
So 1 minute. Done, sir.
So if ever you are in an accelerating frame, what did you get omega to be? Omega is root over of a naught square plus g square by f. Time period is 2 pi under root L by root over of a naught square plus g square. This is what you derived right now. Do you agree with this?
Yes, sir.
2 pi under root L by g effective. What do you mean by g effective here? What do you mean by g effective? G effective is the resultant acceleration on the bob due to all the forces. This is MA naught, this is MG. Listen carefully. If this is A naught, G effective is the resultant acceleration due to all the forces acting on it except forces along the length of the string. Why didn't you take tension in G effective? Because you're not getting it. Why are you not getting it? Because tension doesn't contribute to any restoring force. Tension is perpendicular to the restoring force. This is that acceleration which is contributing to restoring force. Forces along the length of the string are not contributing to the restoring force. Is that point clear? G effective is the resultant acceleration due to all the forces acting on it, except for forces along the length of the string. Why don't they come into the picture? Because they don't contribute to the restoring force at the first place. Questions based on this. Suppose this is an elevator and the elevator is moving upwards. What will be the time period? 2 pi under root L by G plus A, because pseudo force will be in the downward direction. Mg plus Ma. What if the elevator is moving downwards? Time period is 2 pi under root L by G minus A.
Yes, sir.
What if I have a bob of mass m and charge q and there is an electric field in the upward direction? Positive charge experiences force in the direction of the field. Negative charge experiences a force opposite to the direction of the field. This is 2 pi under root L by G plus, G
G
minus
minus.
QE by M, because QE will be in upward direction,
Yes, sir.
right? I am running short of space. Now I'll take negative charge here and show you that it will be G plus QE by M. Take it down to here.
Sir,
Hmm.
sir, the field will accelerate the charge upwards, right?
Right. G is in the downward direction. So G minus QE by M
Oh,
over.
right. Okay, sir.
Done, sir.
Wait a minute.
Now, what if the bulb has negative charge and you have switched on an electric field this way? Time period will be 2 pi under root L by G plus QE by M. Because negative charge experiences a force opposite to the direction of the field. So G and QE are in the same direction. So far, so good.
Yes.
Yes, sir.
If I have Q naught here and Q here, what will be the time period? 2 pi
By
under root.
under L by G plus QE by M. नहीं, sorry.
K
uh,
Q
K Q Q naught
Q naught by
by M.
L square.
L square
L
by
square.
M.
by M, हाँ.
Yes, sir. L cube by K Q naught by M. Huh?
In the direction of tension.
हाँ. नहीं.
Ooh.
K, Q,
हाँ.
Q naught is along the length of the string. It will not contribute to any restoring force. Cheating कर रहे हो यार. यहाँ
हाँ,
पर
वही.
it is along
वही
the
sir.
length of the string.
वही sir.
वहाँ तुम ले लिया. Here it is not along the length of the string. ध्यान से देखिए. EQ is this way. Here it is not along the length of the string. EQ is this way. But here KQ Q naught will be along the length of the string. KQ Q naught by L square is along the length of the string. Will it contribute to restoring force?
No.
No.
No. Hence, keep your eyes open. They will give you n number of forces along the length of the string. Ignore. They will not contribute to the restoring force. Every question put on the board has been asked in some or the other test. Right from here.
Base tests.
No. Entrance examinations. J mains, J advanced, some MCET.
Sir, can you explain the minus Q charge one again?
Negative charge experiences a force opposite to the direction of the field. Positive charge, what is the direction of field? Force experienced by unit positive charge?
Yes.
So negative charge will experience a force opposite to direction of field.
Oh, okay.
G is in that direction, QE is in the same direction. G plus QE by M.
Okay.
लास्ट वाला एडवांस सा क्वेश्चन है क्या?
याद नहीं यार, कौन सा टेस्ट में आया है मुझे याद नहीं।
ओके सर।
मे बी जेई मेंस का टेस्ट था, एडवांस। Cheapest question asked in this category is spring mass system inside an elevator. Now this is accelerating upwards. What will be the time period?
Two pi under root L by G.
L by G.
2 pi under root L by G. Because the spring has a sorry M by
हाँ वो
K.
M by K.
यहाँ पर G
Sorry,
है ही
sorry.
नहीं, G effective का सवाल है ही नहीं. Very cheap trick played. 2 pi under root M by K. G है ही नहीं. You are placing it inside an elevator. You give charge and subject an electric field. You give minus Q subject an electric field. Makes no difference for me.
वो mg के साथ cancel हो जाएगा.
Amplitude. Time period will be 2 pi under root M by K. That's all. G doesn't exist in that particular formula. So G effective का सवाल है ही नहीं.
So I didn't understand why isn't G in the picture?
G उसका derivation याद है कि नहीं आपको? Derivation में आपको G नहीं आता है.
हाँ.
K
mg के साथ cancel हो जाता है.
Cancel हो जाता है.
Cancel हो जाएगा. Mg and Kx naught will get cancelled out. So G effective इसका formula में है ही नहीं. So G है ही नहीं तो G effective का सवाल है ही नहीं. So when they give you such an expression with charge Q and electric field upwards, time period will not change. Time period will remain 2 pi under root M by K.
Sir, it is because the spring is already extended in an equilibrium position, right?
The equilibrium position will shift. If it is moving upwards, Mg pulled it down. Ma will pull it further down. Equilibrium position will shift, but not the time. Amplitude will change.
Yeah, there will be a term like M, like wherein M of G plus A and Ky will cancel each other. So in the calculation.
Forget about it. Don't worry. Can I have the board?
Yes sir.
Yes, sir.
Capital Q is fixed here. Is fixed here. Small q, this distance is d, this distance is d. Small q of mass m moved by a distance of x towards the right. X is much smaller than d. Small q is moved towards the right. Don't you think this repulsion will be greater than this repulsion?
Yes,
Yes,
sir.
sir.
At the
SHM
center, force on small q is 0. At the center, force on small q is 0. Right? But when I moved it to the right, this repulsion will be greater. What will be the restoring force? Will be this repulsion, K capital Q small q by d minus x whole square, minus this repulsion, K capital Q small q by d plus x whole square. Till here, is everybody convinced?
Yes, sir.
Yes, sir.
This should be equal to mass into acceleration, K capital Q small q d square minus x square whole square. This will be 4dx. Yes or no?
Yes sir.
Yes.
Right? d2x by dt square is equal to k capital Q small q by m. 4 comes here. I'll keep x here. Now observe this. Numerator I have a d. Denominator, you gave me d is much greater than x. D square will be yet more greater than x square.
Yes.
So d square minus x square, I can keep it as d square. D square whole square is d to the power 4.
Oh,
Have one d in the numerator. So this will be dq. Say something.
yes, sir.
The particle will perform.
Yes, sir.
With an omega under root 4 capital Q small q k by m dq. What if the same problem is tilted this way? Capital Q and capital Q is fixed. Fixed. Minus small q is kept at the center. This distance is d. This distance is d. If I move minus small q to the right, it will accelerate into capital. If I move it to the right, it will be further attracted by capital Q and it will accelerate into that. Agreed?
Yes,
Yes,
sir.
sir.
Suppose I move it this way such that y is much lesser than d. It will have force of attraction this way and this way. Horizontal components cancel out, vertical components will add up. M d2y by dt square is 2f. If I take this to be f, this to be theta, 2f cos theta. M d2y by dt square 2k capital Q small q by, what is this distance? Whole square. Y square plus d square. Cos theta is y by root over of y square plus d square. K capital Q small q by y square plus d square. Agreed?
Yes,
Yes.
sir.
Yes, sir.
d2y by dt square is 2k capital Q small q by m. I'll keep y here. Denominator will be y square plus d square to the power 3 by 2.
Yes, sir.
Yes, sir.
Y is much smaller. Did I go wrong anywhere? Did I take it correct? 2f cos theta, right?
It's correct.
Cos theta will be adjacent side by hypotenuse.
Correct, correct.
And here also this. So what am I left with in the denominator? dq? Do I get my omega?
Yes, sir.
Yes, sir.
Something similar to this you have done in gravitation, if you people remember. In gravitation, you take the mass here, there will be force of attraction. Instead of K, it will be G, capital M, small m. Right?
sir.
In gravitation, this situation is not possible because there is no repulsion in gravitation. In gravitation, only the situation is possible. In electrostatics, because there is repulsion, this situation is possible.
So here I can't take cos theta equal to 1.
Theta is not 0 no yaar here. Y is small, but not theta tending to 0.
So why are you
But
always
behind
writing?
also the condition was this only.
No, we didn't apply cos theta is small here. Theta is
The
small for
accelerated frame derivation.
Wow, phi is small. In accelerated frame, you took a simple pendulum. For a simple pendulum, this angle must be small. Only then this will be x by L. In a simple pendulum, this theta must be small. That is the requirement of simple pendulum. That phi will incorporate here.
Sir, over here, theta is almost 90 degree, right?
Theta is
Theta is
large.
almost 90 degree.
Theta will
Yes,
almost
very
be pi
large.
by 2, so I can take it as 0.
No?
Hey, y is small means theta will be close to 90 no yaar.
Yeah, so I can take it as 0.
Large. Theta is large, but not 90. Don't put it that way. You want to put cos 90 is equal to 0, then there will be no force on it. I see there is a force acting towards. Theta is large, but it's not tending to 90.
So
Limits may for you, this is taught in the start, sin theta, cos theta. Is that covered for you?
लिमिट्स
yes,
खत्म
sir.
होके
Yes,
तीन
sir.
Limits
चैप्टर हो
खत्म है
गया
sir.
सर.
तो 3
भाई
चैप्टर हो गया लिमिट का.
हाँ.
This doubt you are not supposed to get. Always
So
remember
Sir, and any which ways you are multiplying here.
limit theta tending
exactly.
to 0, sin theta will be theta. Limit theta tending to 0, cos theta will be 1. These are standards which we will not deviate from.
तो ट्रिग्नोमेट्री के बाद ही यूज करना चालू कर दिया था ये.
Fine.
Sir, why are you constantly writing acceleration as d2x by dt square and not just leaving it at a?
In some places, we take this distance as a. Now,
Oh.
two a's in the equation will create confusion. That's why I'm writing it as d2y or d2x. Some places, what we do is this restoring acceleration be a le lete, this distance be a le. So I have this very bad habit of using the same symbol for two parameters. So to avoid that confusion, I'll always keep it this way in a section.
Okay, sir. Okay. Thank you, sir.
Tell me when.
Sir, done.
You will solve this. This is positive charge, capital Q, ring of radius R. This is fixed. You have a small charge minus Q and mass m slightly displaced to the right, x much smaller than r. It will tend to come back. It will perform SHM, find its time period. This is minus Q, remember. If it were plus Q, it will not come back.
Done, sir.
सर ढूंढना क्या था acceleration.
I want the time period of the oscillation.
Okay.
What will be the restoring force? Restoring force is M into E. Sorry, Q into E. Q into K capital QX upon R square plus X square to the power 3 by M into D2X by dt square. You know what next? Next step is your answer. X is much smaller than R. X square will be yet more smaller than R square. And hence you will get d2x by dt square. Bring M to the denominator. You get omega. Now we introduce what we call as a dipole. Di in Greek representation means two. Di in Greek representation means two. Right? You will have minus q plus two poles, one negative and one positive will create a dipole. Two poles, one negative, one positive. You have no chance in changing the configuration. How much of a charge you have got here, you should have the same charge opposite in sign. We take the length of the dipole to be 2L. Generally, in a bar magnet, we take the length of the bar magnet to be 2L. It is a replica there. That is also a dipole. That's a magnetic dipole. This is electrostatic dipole. There is something called dipole moment. Dipole moment defined as Q into length of the dipole. Charge into length of the dipole measured in Coulomb meters. You put a vector sign on the top, implies it is a vector. Direction of dipole is from negative to positive. Direction of the dipole is from negative to positive. Right? Dipole moment is Q into 2L Coulomb meter. Direction of dipole is from negative to positive. This is by definition. Take it down till here.
So why you took 2L?
Now only HCV took it as L. It is a general denotion that we take length of the dipole as 2L. In bar magnets, magnetism, they take it as 2L. So that's used all through. Magnetic dipoles, electric dipoles, we take the length as 2L. Tell me when I can rub the board.
Yes, sir.
Suppose you have a dipole placed inside a uniform electric field. Conditions apply. Uniform electric field. Positive charge experiences a force in the direction of the field. Negative charge experiences a force opposite to the direction of the field. Net field is zero. Net force is zero. Why is the net force zero? QE and QE will cancel out each other. So is it always true? Yes, always true. A dipole placed in a uniform field, but it should be uniform. If the field here and field here is not the same, the net force need not be zero. But it should be uniform. Field here and field here, if it is not the same, then the force need not be zero. So it must be uniform. Field force on a dipole is always zero. How about torque? This distance is L, this distance is L. Torque is QE into 12 sine theta. Q into 12, I will put it in one bracket, E sine theta. What is Q into 12? Dipole moment.
Sir, yes, sir.
So magnitude of the torque is P E sine theta. With direction, it is P cross E. Observe the direction. Dipole moment is in this direction. And it is giving me clockwise. Dipole moment is along my marker. And I know the torque is in the clockwise direction. To get clockwise, it should be P cross E. P cross E. If I take E cross P, I'll get anti-clockwise. And here the torque is in clockwise direction. So torque is P cross E. Dipole moment cross electric field. So far, so good. Yes or no?
Yes, sir.
So how would we find theta?
How will we find theta? Theta will be given in the question.
Acha, okay.
Right? Now, if theta is small, if theta is small. Now, before that, raw deal. Now, I know that torque is clockwise. So, the dipole moment tends to align in the direction of the field. So, remember this. This torque will always tend to align dipole moment parallel to the field. If I keep a dipole moment like this, it will tend to align this dipole moment in the direction of the field. Right? But just imagine, when there is a torque in the clockwise direction, the dipole moment is rotating. When it comes here, it will have some angular velocity.
Yes, sir.
This angular velocity, it will tend to go towards this side, but now torque is in anti-clockwise. So it will decelerate, bring it to rest. Again, it will bring it back to the equilibrium. It has some angular velocity. It will come till here. and hence the dipole moment will oscillate. If theta is small, it will
SHM.
perform an SHM. Have a look. If theta is small, torque is P sine theta equated to I into alpha. What is I?
Moment of inertia.
Moment of inertia. I is moment of inertia. It purely depends on the paper setter. If he is connecting these both by a thin rod with mass or without mass. If he gives you point masses here, you know how to calculate the moment of inertia.
Yes, sir.
For the dipole length, this rod may have mass, may not have mass. Point charges may have mass, may not have mass. He can play either way. He can give you rod with mass, point charges with mass, one of them without mass. However he gives, you should be able to calculate the moment of inertia. If theta is small, P theta by I is alpha. Alpha is minus of P by I into theta. What will omega be equal to? P by I time period 2 pi under root I by P E. P is dipole moment, E is the electric field, I is the moment of inertia of the dipole. It will perform a simple harmonic motion provided
Theta is small.
Theta is small.
theta is small. Three things that you should know: torque acting on a dipole in an electric field. If theta is small, it will perform SHM with this time period. And something before this, net force on a dipole is zero provided
Uniform field.
the field is uniform. Net force is zero on a dipole provided the field is uniform. All 3 points are important. Net force zero only if the field is uniform. Torque P cross E. SHM provided theta is small with this time period. This is a very important application which I will explain. Take it down till here.
What was P?
This way.
Dipole moment.
Dipole.
Write down what was P. वह हमने के बाद पूछ रहा है. P is U into 12 लिखा है मीटर, इसके जस्ट पहले लिखा है.
ऐसे हम लोग वही हैं.
Now, in the video lectures, we are missing whole of this. In live lectures in the class, every time, every year I used to see some or the other student will lose track of what I am saying. He'll keep daydreaming or is not concentrating. I make him stand and I ask him, PE is the potential energy of what? He'll look at the board confidently, dipole, sir. Bhai, P is not the potential energy. P is the dipole moment, E is the electric field. You ask him P is the potential energy of what? Confidently, he'll tell you dipole moment in the electric field. And somebody is asking this. See the direction of the torque, P cross E. The torque on the dipole is acting in such a way such that it will align in the direction of the electric field. P cross E is clockwise. So it is tending to align the dipole in this direction. That means torque will always tend to align the dipole moment parallel to the electric field.
So net force is 0 only because it is uniform electric field, right?
Right. If it is not uniform field, net force will not be 0.
Okay.
सर हो गया है, go ahead.
So 1 minute. Done, sir.
If I have got minus q charge here, minus q charge here, and 2q charge here, this is an equilateral triangle of side L. And they ask you what is the net dipole moment. Dipole के लिए remember you should have plus q and minus q, right? Will form one dipole.
Yes, sir.
Now split 2q as q and q. Minus q and q will form one dipole. Minus q and q will form one dipole. You know the dipole moment and the angle between them. Can I get the resultant? P is q into L. Length of the dipole here is L. This P is also q into L. Angle between them. This angle is 60. This is 60. Resultant dipole moment will be root over of QL whole square plus QL whole square plus 2QL into QL into cos 60. This is the net resultant dipole moment. Should not be difficult. In fact,
Yes, sir.
H2O molecule means hydrogen positive, oxygen negative. Negative to positive will form one dipole, negative to positive will form one dipole. Do we know the angle here?
0.5 degrees. 109.5 degrees.
107.5.
Now that you know the angle, can you calculate the resultant dipole moment?
Yes, sir.
And water is called a polar solvent because it has a net dipole moment. Hence, water is called a polar solvent because it has a net dipole moment. थोड़ा ध्यान से सुनिए. It's an application which you may not require for the JEE, but you need to know. Every form of cooking takes heat from external to internal. You cook food, either using boiling water or steam or oil. These are the three main sources. Or you burn it completely on fire. These are the only sources in which you can cook food. Either any form of food. Either you expose the food directly to the fire, burn it, or you boil it in steam, water, or oil bath. Yes or no?
Yes, sir.
Yes.
Suppose at home, now you want to fry a samosa, a complete big piece of a samosa, you have to dip it in an oil bath. At home, when we fry vegetables, we don't want to use so much of an oil. Hence, we slice the vegetables into small pieces and fry them with 1 or 2 teaspoons of oil because we want to use lesser oil. But for that, heat should enter the food particle deep inside and it is cooked. This is the basic principle of cooking. Except for a microwave oven. Microwave oven doesn't send heat from external to internal. Microwave oven doesn't generate heat at the first place. Then how does it cook food?
Radiations.
Sir, it
Understood
makes
their
the
analysis.
molecules vibrate faster. And
All of you switch off your mic. Let me do the explanation. And you have to hear to me because you paid for it. Aai baat samajh mein?
Okay.
Water will have a net dipole moment. In your microwave oven, red colored marker is the electric field. The electric field is oscillating. क्या कर रहा है electric field?
oscillating.
Oscillate कर रहा है. So when the electric field is like this, the water molecule inside the food has a net dipole moment along the blue mark. Torque will act in such a way such that the water molecule's dipole moment aligns in the direction of the field.
Yes,
Yes.
sir.
Torque will act in such a way such that the water molecule's dipole moment aligns in the direction of the field. But before that can align, electric field direction change. Now water molecule will start trying to orient in this direction. But before that happens, electric field direction change. Water molecule will try to align in this direction. We are making the water molecule oscillate inside. We are generating enormous friction between the water molecule and the food particle. That heat inside will cook the food for you. क्या बोल रहे हो यार? मतलब without water molecule you cannot cook food inside a microwave oven. Either oil or water molecule is compulsory. Popcorns में कौन सा water molecule है? I'll come to that. Don't jump to conclusions. You cannot cook rice without water. How do you justify? Give me a proof that water is the key factor in microwave oven. When you people buy a veg puff and you eat the veg puff removed from the microwave oven, the outer skin of the bread, which is dry, crispy, thin layer, will not be hot. When
Yes.
the curry touches your tongue,
It is.
it is hot. The veg puff, the outer bread is dry. You can feel that the outer bread will be dry. However carefully you eat, small pieces of that bread will fall down because it's very crispy. It's very dry. Curry inside is dead hot. Do that with a samosa. Take the samosa, keep it inside the microwave oven, pull it out. The outer skin will not be hot. Curry inside will be dead hot. You can try this as an experiment. Buy a samosa, sprinkle water on one side of the samosa. Sprinkle water, don't make it completely wet. Sprinkle water on this side of the samosa. Take a marker and mark it on one side. Which side you have sprinkled water. Why do I mark here? I know I have sprinkled water on right hand side. The plate inside will be rotating. And that's for a specific reason. It is not fashion. Fashion ke liye ghumate nahi. There is a specific reason for it. So hence put a mark on the side on which you have sprinkled water. After 5 minutes, remove the samosa and see the side on which you sprinkled water will be very hot. Side on which you didn't sprinkle water will not be that hot. So water is the key factor. The oscillation of the water molecule generates enormous heat for the food to get cooked. तो पॉपकॉर्न्स में कौन सा वाटर स्प्रिंकल कर रहे हो भाई साहब? हम वाटर नहीं स्प्रिंकल कर रहे. Popcorns pop up. There is oil in it. The oil oscillates and popcorns require very less amount of heat. Popcorns, if you are doing it in a pressure cooker, they don't even let you close the lid. They'll tell you keep the lid inverted, keep little bit of a gap. In 2 minutes, they'll start popping up. Quantity of heat required for popcorns is much lesser. The oil on it is surplus for it to generate the heat. Papad, the water vapor on it is surplus for it to generate the required amount of heat. But for all this, the water molecule is essential, or oil. If not, it will not get cooked. The oscillation of the water molecule is the key catch. So why do we call it microwave oven? If electric field is oscillating, I am under the impression microwaves go into the food and cook my food. Abhi bol rahe ho, microwaves don't go into the food only. It is the water molecule which is oscillating. Call it infrared oven. Sophisticated to dikhega. We call it microwave oven because the frequency at which the electric field is oscillating is microwave frequency. We call it microwave because the frequency at which the water molecule, the electric field is oscillating is microwave frequencies. Why did they select that frequency? That is the natural frequency of the water molecule. When the external frequency matches the natural frequency of the body will vibrate with maximum amplitude. Phenomena is called
Resonance.
Resonance.
Water molecules' natural frequency is microwave frequencies. In the spectrum, what is the microwave range? In wavelengths, 1 centimeter to 10 centimeters is microwave range. 1 to 10 centimeters is microwave range in wavelength. So that's a natural frequency of the water molecule. When external frequency and the natural frequency of the water molecule are the same, the water molecule will vibrate with maximum amplitude. It generates maximum heat and the food inside will get cooked. You are never ever supposed to keep your hand inside the microwave oven when it is on. The water inside will start oscillating. It generates enormous heat. That is the reason why, for a safety precaution, any microwave oven will have sensors fit to the door. The moment you open the door, the power will be switched off. There will be two sensors fit to be on the safe side. Anytime you open the door, the power will get switched off. To play it safe, please tell your people at home, do not open the door without switching off the microwave oven. Only after, generally impatience. We keep that for 10 minutes. After 5 minutes, we think kafi hai nikal. Switch off the supply and remove. You are not supposed to keep. The gloves which you get are not preventing the electric field from entering in. They are used only to hold the hot container. The gloves are made of good thermo wool or thermocool materials so that the heat is not transferred. It doesn't prevent the electric field. So technically, you are not supposed to keep your hand inside the microwave oven when it is on. But then you have two sensors which will generally not fail you. When you open the door, the power supply is switched off. There is another important reason as to why the plate inside is rotating and why you cannot keep steel containers inside the microwave oven. Will be explained at the right time when we complete those topics. When standing waves are taught, I'll explain why the plate should be revolving. Standing waves are not yet taught to you people, right?
No,
Yes.
sir.
So once that's taught, I'll explain why the plate is revolving. In the chapter EMI, will tell you why you cannot keep steel containers inside a microwave oven. The explanation is half done. Now you know how to cook food in a microwave oven, right?
So,
So if I put my hand in the microwave,
butter, so butter, ghee, and oils are organic molecules which have very low dipole moment. So, how does that explain? Sir, am I audible now?
Your voice is resounding. फिर से बोलो.
Sir,
audible
he's
now?
saying
Sir, I'm saying that oils and butter, organic molecules having very less dipole moment. So, how does that explain that popcorns are cooked in microwave?
The heat required is also very less, no yaar. Popcorns ले कितना heat चाहिए? Very less. प्रेशर कुकर का lid तक बंद करने नहीं देते. They keep it inward. Oils and other components that you have got have lesser dipole moment, but yet they have a dipole moment. Oils mean there are different types of dipoles. Quite a few of the vegetable oils are dielectric materials with dipoles. How much do you think is the dipole moment of oil? It is not very less to my knowledge. It's quite good quantity. First dielectric, when I introduced, did I show you that dielectric was formed from dipoles? Right? This is a dipole. And these dielectrics, all edible oils are good insulators and good dielectrics. They have good amount of dipole moment. What made you think dipole moment for oil is lesser is a piece of surprise to me.
sir, in a microwave, suppose there's an oscillating electric field, and I just put my hand or any organic part inside and outside for a very small amount of time. So in that small amount of time also, will it generate sufficient heat to cause any damage to my hand?
Yes.
कितने कम टाइम में मतलब डाल के निकाल
Microwave frequencies देख लो, at that speed you cannot keep your hand. Microwave frequencies, you think you can insert so very fast and remove it? It will create damage. That's why the ISI marked microwave ovens will always have two sensors fitted to the door. The moment you open the door, the power supply will be ruthlessly shut off under any circumstance. If the power supply doesn't get shut off, do not use that microwave oven.
So what material blocks electromagnetic waves?
This is called shielding. Faraday's
cage.
Man, we will come to that in detail in the another 2 lectures from now.
So we covered it a bit in the previous chapter.
But in detail we'll deal with in another 2 lectures. बहुत ही detail में जाए.
Yes, sir.
Take it down till here.
So one more doubt. If I put a magnet inside a microwave and I start it, will it keep oscillating up and down?
Magnet is for a magnetic field. Electric field, why will it produce a magnetostatic oscillation?
So if there's an electric field, there has to be a magnetic field to counter it, right?
Now that piece is very different when compared to what you're asking. An oscillating electric field generates a magnetic field, right? That is electromagnetic wave. When we come there, then we will decide about magnetostatics. First, we are introducing electrostatics without magnetics. Then we'll introduce magnetostatics without electrostatics. Then we will merge both of them. You will be amused to see that electromagnetic wave will neither oscillate an electric dipole nor a magnetic dipole. Electromagnetic waves nature is very neutral.
Sir? Sir, why does the microwave beep for like 2 to 3 seconds before before like shutting the
बताने
light.
के लिए होता है वो क्या करते हैं
Okay, that has got nothing to do with the working. It is just waking you up. आकर collect कर लो तेरा food.
Alert.
And sir, can you explain that part? Can you explain that part where you said 1 second? That torque will always tend to align P parallel to E.
Yeah, direction of torque देख लो. This is taking my. See the direction of the torque. This is P. This is. Verify the direction of the torque. Torque का direction पता? Do you know how to find out the direction of torque?
Yes, sir.
See how it works.
Okay.
Sir, here dipole will tend to be in the direction of electric field, na? Sir,
No,
so
आगे तो
it will be anti means parallel, but opposite direction or same direction? Same,
in
na?
the direction of the field. People should be hand upside down here.
Yes, sir. Yes, sir.
Now Sahil says, I have searched Google about microwave and the government website also says it's wrong that there are microwaves used inside the microwave. वही तो समझाया ना यार मैंने भी. मैंने कुछ और समझाया क्या आज? What did I explain?
Government website about microwaves.
It seems he searched a website.
No, sir. The government website says that there are microwaves used. They are also saying it wrong.
अब हमने भी वही तो बोला ना यार हमने क्या बोला है microwaves are not used it is electric
No, sir.
field.
Yeah, I am saying that the government website is stating that microwaves are used.
Microwaves, see Halliday Resnick, it is not the government website, see Halliday Resnick. The water molecule, why it is microwave means electric field is oscillating at microwave frequencies. Microwaves don't go into your food to cook the food.
Okay.
So molecules having zero dipole moment.
Turn off your mic. This is the dipole moment. This is the oscillating electric field. Do you see the oscillation of the dipole moment?
Yes, sir.
This is the microwave oven principle. Now, why they wrote magnetic field here is an oscillating electric field will always produce a magnetic field. Hydrogen and oxygen dipole moment. Water molecule. Are you able to see this?
Yes, sir.
Yes, sir.
No. Every oscillating electric field will have a magnetic field. This so many number of times it oscillates in 1 second. Value is given here just for fun. Units, tens, 100, 1,000, 10,000, lakh, 10 lakh, crores. This is the way the dipole moment oscillates. Fine.
Yes, sir. Sir, so those bulbs are specialized to give more of infrared or what?
What are specialized to be infrared?
Those bulbs in the microwave.
Bulbs.
Bulbs.
Tube light.
They are visible light only. They are infrared. तो light
They
दिखाई
said
देता है आपको.
infrared.
But light दिखाई देता ना यार.
हाँ sir.
Now listen. Homework. HCV first 70 problems except the 51st. HCV exercise 1 to 70 except 51st.
Okay,
Except the 51st. 51st is a typical problem of finding out amplitude in SHM, which has not been taught to you people. Hence, 51st I kept exception. I'll explain it in the next class. First 70 problems.
So molecules having zero dipole moment cannot be heated through a microwave?
Cannot. We need a dipole moment for the molecules to be oscillated in an electric field.
सर कंटेनर क्यों गर्म होता है?
क्या?
कंटेनर क्यों गर्म होता है?
Because of the heat generated by the food.
Okay, sir.
क्या bro?
The food will be hotter inside the microwave and the air around will not be that hot. That heat is because of the food heat generated by the food.
Sir, sometimes it happens that the container is more hot than the food.
No, you're mistaken. You're touching the container with your hand, not
Yes,
the
sir.
food particle.
Okay, sir.
Sir, will we complete the chapter before MT?
Pardon?
Will we complete the chapter before MT?
Let us see, may not be complete Gauss law, some part of Gauss law.
Sir, due to this oscillation of oil and water inside the food, the milk is not hot inside. We should not
Milk can
boil
be
the
boiled.
milk
Milk
inside
has
the
some water in it. Milk
Sorry,
has
sir?
some water in it. Milk can be boiled in the microwave oven.
Sir, but it will destroy the proteins inside it.
वो biology मुझे पता नहीं.
Yes, sir, that's why.
Then don't. अब मैं थोड़ी जबरदस्ती कर रहा हूँ कि माइक्रोवेव ओवन में मिल्क बॉयल करके पी लो. कुछ भी